So friends, welcome to my YouTube channel. On this channel, I will be uploading videos related to embedded systems and digital electronics. So this is going to be the first video of my channel, and in this video, I will cover what are instruction sets and its related concepts. So I will cover all these instruction sets in two videos. So this is the first part. So let's discuss. Okay. So what is an instruction set? An instruction set, also known as the instruction set architecture, short for ISA, is a collection of all the instructions that a processor or the CPU can execute. It defines how the software communicates with their hardware, mainly the CPU part, right? So whatever the instruction or the commands we give to the CPU to execute, that comes under the instruction set, right? And let's discuss the components of the instruction set. So basically there are total 4 components of the instruction set. The first one is the opcode, which is short for the operational code. Okay, it specifies the operation to be performed by the CPU, like your addition, subtraction, loading of the data, okay, etc. The second component is operands, like if we add 2 plus 5, so here 2 and 5 are operands, right? So likewise here also we have operands, and these operands are data values or the addresses involved in the operation, and these operands can be registers, constants, memory addresses, etc. I will discuss what are the registers in the further parts of the videos, so don't worry about that. Okay. The third component is the instruction format. It defines how the bits are the layout. Okay, what should the layout of the bits? So it contains three things. First one is opcode, operands, and the mode bits. What should be the mode of the bits? Okay, I will discuss what are the instruction set, format in this video itself in detail. The fourth component is addressing mode. It specifies the location of the operands. Okay, the CPU can identify the location where your operands are located, like immediate, direct, indirect, register, and there are some more. Okay, and let's discuss about the types of the instruction. Don't worry, I will cover the point number 3 and 4 in detail in this video itself. Okay. Let's discuss what are the types of instructions. There are total 5 types of ISA. First one is the data movement, which moves the data between the memory, registers, or the input out. Right? Suppose, for example, we take move R1, R2. So here R1 and R2 are the registers, right? And move is the operation or the instruction. The second ISA is arithmetic, which perform mathematical calculation like adding. So here R1, R2, R3 we have taken. So it means adding the data present in R2 and R3 and copy it to the R1, right? The third one is logical, perform bitwise logic like AND, R1, R2. I will discuss what is the meaning of all these in detail. The fourth one is the control flow, change execution sequence, right? What should be the sequence of the execution of the instruction by the CPU? Like JMP, JMP means jump, call, and read. The fifth one is input output instructions, means reading or writing from the devices, like input and output. Okay, and mainly there are two types of ISA. First one is the RISC architecture, second one is the CISC architecture. I will not cover the details of this in this video because otherwise the video would get too long. I will cover the instruction set architecture in further videos. Okay, so here let me give you the brief about of both of them. RISC stands for Reduced Instruction Set Computer, which is a simple fixed length instructions, and it consists of fewer instructions, but it is very fast, right? Examples include like ARM, MIPS. So basically this type of architecture mainly used in the microcontrollers, okay, where we have to deal with real-time constraints. The second one is the CISC architecture, which is complex instruction set computer. So basically this type of architecture used in your laptops and high-end computing machines. And it mainly consists of the more complex instruction, variable length instructions, fewer instructions per program, but each instruction may take longer time to execute, right? So all types of instructions that we have discussed here, these 5 architectures, these all the architectures included in RISC as well as in CISC. Okay, so let's discuss some examples of the and RISC. Like your RISC consists of the ARM, MIPS, RISC V. Actually, it is not V. Most of the people confuse it with V. Actually, it is RISC 5, right? And it is in Spark. Here are the examples of the RISC architecture. Now, CISC architecture examples include like x86. You probably have seen your files in C drive, like here, program files x86. So basically, your laptop is using this kind of architecture, CISC. Okay, and x86 64. And there is one more example, WAX. So there are a lot of architectures included in RISC as well as in CISC, right? Let's discuss all these points in detail: data movement, arithmetic, logical, control flow, and input output, right? So here I have given examples of ISA instruction and their meanings, right? So you can read from here. Like in x86, here I have taken an example of move. In ARM, I have taken an example of LDR, means load value from memory at R1 into R2, right? Here value means the data. Here word also means the data. In MIPS architecture, we use the LW for load. Okay, so there are many kind of you can say symbols to represent different kind of instruction in each ISA. I will discuss when we use BX, AX, R, and $T. Okay, let me show you the brief about it. So here you can see tip. I have written 3 tips for you. For x86 architecture, we use AX, BX, SI, DI. All you can see here. These are the 16-bit registers used in this mode. Okay, and EAX, EDX are the 32-bit register. RAX and RBX are 64-bit registers. And for ARM, we use notations like R0, R1, R2 up to R15, and these are 32-bit registers. And similarly, for 64-bit register, we have X0, X1 up to X30. And here we also have the 32-bit register also in ARM, like W0, W1, up W2 up to etc. Right? And for MIPS, we use notation for like $T0, $S1, etc. Like in MIPS 32. So these are 32-bit register, and in MIPS 64, these are the 64-bit registers. So it might look similar from the notation, but they are different. The use depends whether you are using MIPS 64 or 32, right? Okay, let's come on to the topic, optional topic. So here R1 is a register, but when we include the square bracket outside the R or the register, it becomes a memory address. It is like a dereferencing a pointer, which you usually have learned in many programming languages like C, right? Similarly, $T0 is register, but when you include 0 outside of that, it becomes a memory address. It means go to that address R1, pick up the data from that address and load it to the R0. Okay, so it means it is kind of a dereferencing the memory address. Okay. The second one is the arithmetic instructions. I've already discussed about that. So here you can see the examples of that ISA and instruction and their meaning. Okay. Similarly, for logical instruction, we have written their meanings and their instruction. The logical instruction include like AND, OR, XOR operation, NOT operations. Okay. Now let us move on to control flow operation. So this changes the sequence of the execution, like jumps, branches, and function calls. Okay. Like JMP label is instruction in x86. It means unconditional jump to the label. And in ARM we have B label, means branch to label. And similarly in MIPS we also have BEQ, this kind of meaning, branch to label if $T is equal to $T1. Okay. Now let us discuss the instruction format in detail. So it defines how the instruction is represented in binary. Okay. That is how the CPU interprets the bits of instruction. So all the instructions that we have written here, move, LDR, LW, add, so these instructions are actually human readable. The CPU cannot understand it directly. So what the CPU does, that CPU actually converts this kind of instructions into binary format. Okay, let's take an example to understand. Like x86 instruction format, So we usually calculate the length of the instruction in bits, like 1 to 15 bits can be the length of the instructions, and it typically have this kind of format. Okay, first one is the prefix, second one is opcode, third one is the mode RM, whether your mode is register or the memory address. Fourth one is SIB, fifth one is the displacement, and the sixth one is your immediate. Okay, so here I have written the meaning of all the components. Okay, you can read here. SIB stands for scale index base byte. Okay, SIB byte means 32-bit mode for complex memory addressing. And please note that SIB it is only used for the 32-bit system. You cannot use it for the 64-bit. Okay. And for displacement means a memory offset. Like if your offset is consist of 8 bits or 62 bits or 32 bits. Immediate means the constant data is being used. Let's take an example like move AX BX plus 4. So here opcode is this one and the mode arm is this one. Okay. Please note that here the prefix is not there. Okay. Only we have included opcode, mode, and the displacement. All the rest of the thing like immediate, uh, displacement, sorry, immediate and this SIB are ignored here. Okay, because it is a simple instruction. Okay, it means copying the 16-bit word from the memory address from this into AX. Okay, so first of all, the CPU goes to that address BX and will take an offset of +4. Okay, that is the CPU will move forward from this BX address by 4 bytes, and whatever the address, sorry, whatever the data will be present at that address BX plus 4, that will be copied and will copy to AX, right? So here word means the collection of 16 bits. Okay, means 2 bytes. As we have the collection of 8 bits called 1 byte, similarly we have the collection of 16 bit called word, one word. Okay, and let's discuss about the addressing mode. So you might confuse that what are these. So I will discuss in this what are these digits or the bits in the second part of this video. First of all, you consider that this instruction might be converted to this kind of binary instruction. As I've already discussed that CPU cannot understand this kind of instructions. First of all, it converts this instruction into binary format. So it might be converted to this kind of binary format. I will discuss what is the meaning of this in the second part. So addressing mode means specify the CPU locates the operands used in the instructions. Like if your mode is immediate, operand is directly in the instruction like this one, 5. If your mode is register, then this one operand is in the CPU register. Okay. So here you can read about that. Let me show you the meaning of all these modes. In immediate mode, operand, like I have taken example this. So operand is 1, 2, 3, 4 H. Now here H means this is the hexadecimal value. Okay, 0x. So whether you write 0x 1, 2, 3, 4 or you write 1, 2, 3, 4 H, both means the same. The only difference is that whether you are using in the Intel format. Let me show you the example. Okay. So 1, 2, 3, 4 H is used in Intel style form, Intel style, and 0x1234 is used in C style coding, C style coding. Okay, both of them converted to 4660 in decimal value. Okay, uh, this value and this value 1234H and 0x1234 both will be same in decimal value, and the decimal value is 4660, right? And in the register mode, I've taken example move AX BX is copying the value from register BX to AX. So I have also written the you can understand from this analogy. Okay, I have written analogy in front of each mode. Right? Let us move on to the direct move. Move AX 1234 as like load value from memory address. Okay, it is also dereferencing. Go to this address and load it to the AX. Okay, it is kind of dereferencing, like you can understand if you have already familiar with C language. Then come on to the register indirect. It is also like a memory address is stored in the BX. Okay, indexed we have SI means uh, it is kind of a shifting. Like if you want to access the element of an array, you can write like this in C. Similarly, this is also analogous to this kind of command. Okay, means here I is the index. Similarly, SI is the index here. And based index with displacement means memory address will be BP plus SI plus 4. So this is a complete memory address. So it is analogous to writing like this in C language. First of all, go to this index in the array I and shift by 4 bytes. Then go to that address, okay, and copy it to the AX. And in the relative mode, we have this kind of instruction I have taken. For example, JMP short plus 5 means jump forward by 5 bytes from the current instruction, right? So that's all for the part 1. I will definitely upload second part of this video also. So whatever the doubt you have in your mind, you can comment down in below. Okay, I will definitely answer them. So thank you for watching this video.